Hey everybody. In this video, we are going to be going through the midterm exam review. Specifically, I'll be going over the Module 1 problems from the review packet in this video. I'll also be creating separate videos for Module 2 and Module 3 as well, so you can navigate each of those specifically and study for them. So in this video, before I get started, I'm going to just kind of break down what your exam is going to look like. Um, your exam consists of 30 multiple choice questions, and you can roughly expect a few questions from each of the three modules across these 30 questions. So on the midterm, you'll see questions that cover topics from Module 1, Module 2, and Module 3. Module 1, which we'll cover in this video, was all about decimals, fractions, and percentages. So let's take a look at these questions on the first page here of the review. So this first question um, asks us to convert this mixed number 5 and 2/3 to an improper fraction. So first off, this value right here is what we call a mixed number. It's because it's got a whole number and a fraction mixed together, or it's being represented that way. And an improper fraction is um, whenever you have a fraction, it looks like that, a number over another number, a over b, where a is bigger and b is smaller. So I'm going to kind of write like greater number over a lesser number. So we want to express this number 5 and 2/3 as a fraction where the numerator is greater and the denominator is less. So whenever you have a mixed number, we want to kind of break this apart and think about what the 5 might turn into if we want it to look like a fraction. And then we also have this 2/3 here. This 3 determines what our denominator is going to be in our answer. So I'm going to just rewrite right here, 5 and 2/3. And we're going to first start by thinking about this 5. And whenever you look at your mixed number, you see you already have a 3 right there. So um, we want to break apart this whole number 5 into 5 fractions all over 3. Since the whole number 5 represents 5 whole units, we're going to also put 3's above here. So as you can see, we've got 5 fractions, 3/3, 3/3, 3/3, 3/3, 3/3. These are all technically ones, right? We've got 5 ones, which become a 5. So I'm going to put like a plus sign in between each of them to show that we've broken apart 5 into 5 separate ones, or 3 over 3, which is equal to 1. So now whenever we have this situation, we can add all of our numerators. And then we also had this extra 2/3, right? We didn't just have 5, we had 5 plus 2/3. So at the end, I'm also going to put plus that fraction that was originally in the mixed fraction, the 2/3. So whenever we have a situation like this where we're trying to combine these fractions together, the denominator is going to be the same in our answer. If they're all the same here, we can add all these fractions together, which means all of our fractions are out of 3 here. So our answer is going to be out of 3, and we just have to add across the top here. Whenever you add fractions, you want to make sure you have a common denominator, which we do, and we just add. So we've got 3 plus 3 plus 3 plus 3 plus 3 plus 2. So that's a total of 15 plus 2 more, which is 17. So our improper fraction, which is a bigger number over a smaller number, is 17 over 3. Let's look at number 2. Number 2 says to convert this fraction to a whole number or a mixed number. So now we're kind of doing the opposite where we're starting off with the improper fraction, since 79 is a bigger number than 8. And we want to make that either a whole number or a mixed number. Now, on the exam, you'll have access to a scientific calculator. So, as you're studying, you can use any scientific calculator. I would recommend using the one that just shows up right here on Google when you just Google the word scientific calculator and you see this scientific calculator right here. This is going to look really similar to the type of calculator that you'll have during the exam. So whenever we're taking a improper fraction, one of the options is it could be a whole number as our result, because a fraction is like the division of the two numbers. So if we just divide these two numbers in our calculator, 79 divided by 8, in this case, we don't get a whole number. We get a fraction, we get a decimal. So this is a situation where we'll probably need to turn it into a mixed number because our answer didn't result in just a whole number with no decimals. It resulted in this decimal value, 9.875. So now we need to think about, okay, it's not going to be a whole number. Sometimes it might be, but this one wasn't. So that's going to be a mixed number. Remember that a mixed number is a whole number with a fraction. So it's going to take on this 8 as the denominator of the fraction, but it's going to have a whole number in front of it. So the way I would address this in converting it to a mixed number is thinking about how many times can 8 go into 79. And the way I like to write it out is just somewhere off to the side. I'll just start counting by 8s. 8, 16, 24, 32, 40, and I just keep counting by 8s. 56, and I want to keep going until I reach a number close or around 79. So 56, 64, 72, we're getting closer, and 80. So 79 shows up right there. Now, how many numbers did we get to before we reached the 79? Well, we did 1, 2, 3, 4, 5, 6, 7, 8, 9. We did 9 values before we got to this 79. So I'm going to mark this as a whole number 9, or even a little bit more specific, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's our whole number. How many times does this fraction over 8 complete the value of 8 before we get to the number 79? It goes up to 72 and then it passes at 80. So we don't want to go one past it. We want to stay right before it. So our first number in the mixed number is going to be a whole number of 9. And you can also see that here in our scientific calculator. We have a whole number of 9, but we do have this decimal afterwards. This is going to be what our fraction equals, this 0.875. So it's going to be 9, and then once we get to 72, how many more do we need to get to 79 now? Well, we're just going to do 79 minus 72. That's a remainder of 7. And that 7 determines that value right there, 9 and 7/8. This is our mixed number. And now if I go to my calculator, right, we had gotten 9.875. The 9 we determined already with this whole number, but this 7/8, what does that mean? Well, if I remember this 0.875 and I just do 7 divided by 8, well, there's 0.875. That's why that we got this fraction of 7 over 8 right there. So just off to the side, I'm going to write as this is 9.875. There you go. There's number 2. There's number 3. It just says simplify. Simplify means to make this look simpler, meaning try to make it have less fractions, or depending on what your answer choices might show you, you'll have to do something to this expression here. Now, in this case, we want to combine all the fractions together. In number 1, in order to combine our fractions, all of our denominators have to be the same number. So whenever we have fractions that don't have the same number, we need to find a common denominator. Find common denominator. So we need to think about what number do all of these have in common in terms of a denominator? What can they all be multiplied to become? So if I think about possible values, um, we might start by trying to multiply a couple of the numbers and seeing where we get with that. Um, so we might try multiplying 5 times 7 or 7 times 2 or 5 times 2 um, to see where we get with those. Another way that I could suggest if you're not sure how to find a common denominator is to list out all the multiples of these three numbers. So over off to the side right here, I'm going to list these three, 5. I'll use a different color for each one, 5, 7, and 2. And we want to determine what the common denominator is here. So I just start counting 5, 10, 15, 20, 25, 30. You just go a few numbers and then try some with the next number, 7, 14, 21. And basically we want to find numbers that match up in this list. Right, so far, 2, 4, 6, 8, 10. Right, the 2 goes a little bit slower because it only counts by 2s. So let me keep counting by 5s and 7s and see where I can get a matching number for 5 and 7. So I just go one more with the 5, and you notice that I get to this 35. Now, there's also a 35 there. So that's a common denominator between 5 and 7. But if I were to keep counting by 2s down here, I would skip the 35 because 2 is only even numbers, 2, 4, 6, 8, 10. We would keep going, right? We would get to, for example, we would eventually get to 30, 32, 34, 36. We skip that 35. So we can't use a 35 as our common denominator. So let's keep going, right? We list out more numbers. Let's keep going with the 5s, right? So we get 40, 45, 50. Our 7s are going to go a little bit quicker, right? 49, 56. 63, 70, 77. Right, let's just jump back up to our 5s again. 55, 60, 65, 70. I know this process takes a while um, because you're listing out all these numbers and you're kind of checking back and forth as you get there. But now we notice again, okay, we have a matching number here, 70. Now, would we ever get to 70 with the 2s? Yeah, we would, right? We would eventually, I'm just going to put dot, dot, dot. We don't have to write them all out, but eventually we would get to like 66, 68, and 70. Right, so there you go. There's your common denominator. This is one method to try to figure it out without, guessing and checking too much. You can also mentally do this and try to figure out with some mental math. But if you don't like to do the mental math and you like to visually see the numbers, this is what I would suggest. Right, so we get 70. Now, why do we do that? Is because we're trying to add these three up. So the number 70 will be the denominator of all three. Right? So what happened was for the 5, we need to think about what did we multiply 5 by to get 70? Well, if you go back down here, it took us 14 numbers to eventually get to the 70. So 5 times 14 equals 70. So up here, I'm going to write this. I'm going to write it like this, 14 multiplied. So I also need to do 14 multiplied there. So 14 times 2 makes this fraction 28 over 70. 2 over 5 is the same thing as 28 over 70. Now we go to the next number, 7 times, this one's a little bit easier to do mentally, 7 times 10. So we need to do 3 times 10, so that becomes a 30. Last one, the 2, we multiply it times 35 to get to 70. So I need to do the numerator also by that 35. So there you go. Those are all now converted into fractions over 70. And just like before, we can now add our numerators together. So when we add those values up, you should end up getting 93 over 70. Let's just verify that. Right, we had 28, 30, and 35. So 28 plus 30 plus 35. So there you go. There's 93. That's our numerator out of 70. We don't do anything with the denominators once they're all converted. We just leave the 70 alone. There you go. 93 over 70. Okay, we have one where we're going to convert to a percentage now. So back in your module 1 notes, we talked about how do you convert a fraction into a percentage. Well, if we have a fraction, in order to get to the percentage, we need to go through a decimal. So we're going to go to a fraction, from a fraction to a decimal to a percentage. So we have currently 27 over 30. So how do we take that fraction and turn it into a decimal? Well, we just straight up divide the values in the fraction. So we're going to do 27 divided by 30 directly in your calculator. And there you go. You get this decimal right here, 0.9. So we get 0.9. And now how do we take this decimal and turn it into a percent? Well, in your notes, we talked about that as well. We're going to multiply by 100. So we just take this decimal, multiply it by 100, and we are going to end up at a percentage. So we have this 0.9 times 100 equals 90%. You could already probably figure that out by the 0.9. But in case it's another type of decimal that has more complicated values in it, you can always safely multiply by 100 no matter what. So in this case, we get 90%, and there's your answer. Let's look at another one where we're going to simplify. So whenever we added fractions, we found a common denominator. You're going to do the same thing when we subtract. Adding and subtracting, we want to always find a common denominator. So find common denominator. So now in this case, we have just 2. So the quickest way to find a common denominator here is to just multiply your 2 denominators. So 8 times 7 is 56. And you could, if you wanted to, just to verify it, you could list out for 7 and 8 these values just like we did on number 3. But you don't have to here. You can just multiply and you'll get 56. So now when we think about this, what did we do? We did 8 times 7. So we need to do 7 up here times the 3. So it's going to be a 21. With a minus in between. And then how do I get from a 7 to a 56? I'm going to multiply by 8 for both of these. Times 8 times 8, so we get 16 up here. So now I just subtract going straight across in the numerator. Our denominator will just have the 56 in there. So equals over 56. When I do 21 minus 16, I get 5. The 5 over 56, there you go. Here's number 6. Number 6 looks like a long word problem, um, but it really just involves your understanding of fractions and percentages and things like that still within this module. So it says if the ratio of A to B is 5 grams of sodium chloride per 4 liters of water. So let's just break that entire sentence up. We see A to B, and then we see 5 grams per 4 liters. I'm kind of just removing some of the extra info in there. I'm just really honing in on what I want to see, right? A ratio, A to B, can be written like this, A to B. And then in the order that the sentence tells it to you in, right, 5 grams per, the per is like this colon I put right here, 5 grams per 4 liters. So 5 grams per 4 liters, just like that. It says how many grams of sodium chloride do we need for a solution of 12 liters to maintain this ratio? Well, we can take this ratio and we can write it out like a fraction, 5 grams over 4 liters. And if we want to maintain a ratio, we want it to be equivalent to the other fraction. And it tells us that the other fraction or the other ratio is going to have 12 liters. So in this case, we want that 12 liters. So we don't know how many grams. That's why it says how many grams, right? We want to figure out what value goes up here. Well, so we need to think about how do we get from 4 to 12? To go from 4 to 12, we're going to multiply by 3. So then up here, I'm going to also maintain the ratio by multiplying by 3. So we end up getting 15 grams to maintain that ratio. So the answer that you would pick here is 15 grams. Number 7 says a 500 milliliter IV bag is 75% complete, or in other words, 75% has already left the bag when it says 75% complete. How many milliliters remain? So math is oftentimes visual, and it's helpful to think of math in a visual way. So we got our IV bag, for example, right? We can think of down here is the level 0 milliliters, right? Since our IV bag is measured in 500 milliliters. So at the top, I'm going to put 500 milliliters. The level up here is 500 milliliters. 0 when it's empty, 500 when it's full. We can think of that as percentages, 0%. And instead of 500, we would think of it as 100% if it's completely full with 500 milliliters. So it's telling us that 75% has already left the bag, right? So now if we think about different points in the bag, right? 75% full, 25% full. Well, don't get this mixed up right here, right? 75% complete means that 70% has left the bag. So what's the level? Well, the level indicated here would have to be at the 25% mark, right? Because the 75% up here has already left the bag. I'll just put a little squiggly so it looks like liquid, right? But 75% complete. So we're being asked how much is left in there. Well, 25% is left, but how many milliliters is that? So we need to think about what these different marks would be on this bag. Okay, so Um, if we were to think about the halfway mark, that would be half of the 500 or 250 milliliters. And now we think about 25%. That's again half of the half, right? 250 milliliters was half of the entire thing. Now we just go one more halfway just between 0 and 250. And that's going to be 125 milliliters. So entirely a visual process here. We end up with 125 milliliters are left. Now, another way you could think about this, or you may have already thought about this, is we could just take the total 500 milliliters and multiply it by 0.25. The reason is because when it told us 75% was complete, that means it's asking us how many are remaining. Remains means the 25%, and that 25% turns into this decimal right here, 0.25. But this is not always clear unless you have experience with this type of a question or you've seen this before. If you haven't seen this before, it's probably better understood visually, because oftentimes you might see this and think, oh, okay, 500 times 75%, and you would have put a 0.75 right here. Well, that would have led you to the incorrect answer. It would have led you to, what's that, 375 would have been your answer, but that's not correct. 375 left the bag. What remains is 500 times 0.25, or 25% of 500, which is 125. Right, so that's why this visual is helpful, because you don't make a mistake when you can see what's going on. And the last one right here for module 1, here's number 8. Number 8 says tritium is a radioactive isotope. After 10 years, it decays to 1/2 of the original amount. After 20 years, it decays to 1/4. If we started with 52 grams, how much remains after 20 years? So the best way to think about this is kind of like, think about, again, sort of like a visual, but you can think of it more of like a timeline actually, because we're thinking about years. So thinking about a timeline, I'm going to put 0 years, 10 years, 20 years. And we started off with 52 grams. So at 0 years, at the beginning, we started off with 52 grams. And it said that after 10 years, it decays to 1/2 of the original amount. So I just divide the 52 grams by half. So I'm going to do 52 divided by 2 here for the 10-year mark. So 52 divided by 2, and I get 26. So after 10 years, this turns into 26 grams. And then in 20 years, it decays to 1/4 of the original amount. So the original amount was 52. 1/4 of that would be whatever we have at 20 years. So we can take the original and divide it by 4, since it says 1/4. 52 divided by 4. So we get 13. So technically, we actually didn't really need to determine that 10-year mark, because we had enough information to go straight to the 13 grams, which was 1/4 of the original amount. So our answer here would be 13 grams. All right, so looks like those are the questions in the review that cover the Module 1 topics. In the next video, we're going to cover the Module 2 questions, which cover the topic of solving equations. So you can move to that video now and review those questions.